Welcome back to our tutorial series for another exciting project. In this project, we will build a basic calculator from scratch. Looking at our final project, you can see a modern calculator design. It includes all the numbers from 0 to 9. We also have the operator buttons for addition, subtraction, multiplication, and division. The design is completed with an equal sign and a clear button labeled with the letter C. You can simply type in any arithmetic problem you want to solve. The calculator will handle your equations and expressions. Let's type in an example, such as 45 plus 42. The calculator will then display the result for you. You can also multiply numbers together with ease. The calculator handles multiplication operations perfectly. We can also clear everything from the screen with a single button press. This resets the calculator completely. This calculator is very straightforward and easy to use. It performs all the basic operations you need. For evaluating the expressions typed into the input, we will use a built-in JavaScript function. This function is called eval. We will learn how to attach event listeners to all these buttons. We will do this efficiently by using a for loop. We will learn how to design our calculator with a modern look. We will use CSS to achieve this styling. You will notice interactive hover effects when you move your mouse over the buttons. We have also applied shadow effects to various elements for a sense of depth. Now that we have seen what we are building, we will begin with the HTML structure. This is the foundation for our calculator project. Let's dive into the HTML structure in the next section. Let us begin our exciting project together. We will create a basic calculator from scratch. For reference and comparison, I have placed the completed final version here. This allows us to compare our current design with the final completed version. We can see how our work measures up against the finished project. You can see the final design we are going to build. We will use this as our reference. Our first step is to build the structure of our calculator. We will begin by creating the HTML part of the project. Our first task involves creating all the necessary elements. We need to display the numbers from 0 to 9. We also need the operator letters and the equal sign. Finally, we will place a container around all of these elements. Now we need to add an input field for our display. This is where the numbers and results will appear. Our first step in this process is to create the HTML file. This file will serve as the foundation for our calculator. To begin, we will open up Visual Studio Code. This will be our main workspace for the project. For this project, I personally use Visual Studio Code. You are welcome to use any text editor that you prefer. The choice is entirely up to you. To begin, you will click on the File menu. Then, navigate to and select the Open Folder option. We are going to create a new folder for our projects now. This folder will hold all of our project files. I will create the new folder on my desktop. This location is convenient for easy access. Let us create a new folder for our project now. We will name this folder Basic Calculator. I will type the name of our project folder as Basic Calculator. After typing Basic-Calculator, I will click the Create Folder button. We then need to select this new folder to open it. This action will reopen Visual Studio Code with our project folder ready. Notice the Explorer section on the left. You can see our Basic Calculator folder is open. We are ready to create our files inside this folder. Every file we create for our project will be stored inside this Basic Calculator folder. This keeps all of our work neatly organized in a single location. Let's close the Welcome tab that is currently open. Now we can create a new file for our project. You can do this by clicking the New File icon. Alternatively, you can right-click in the Explorer area and select the New File option from the menu. We are going to create our HTML file now. You can name this file anything you like. The only requirement is that it must end with the .html extension. For our project, we will use the standard name index.html. Our new file is currently empty. We can use an exclamation mark to generate a boilerplate template. This gives us a great starting structure. When you type an exclamation mark, the editor's abbreviation system will suggest a boilerplate. This boilerplate provides the initial template for your website. This foundational template includes a title element for your page. Simply click on the very first suggestion from the editor. This action will automatically generate our complete boilerplate code. The boilerplate includes the essential document type declaration. The document type declaration tells the browser which version of HTML your page is written in. This is essential for ensuring the page renders correctly. We write the word HTML inside the opening tag. This specifies the root element of our document. For the HTML5 standard, you simply need to write the word HTML here. This declaration is all that is required. Next, we have the HTML tag itself. This main tag contains two important sections. These sections are the head tag and the body tag. This lang attribute defines the language of the entire page. It clearly tells the browser which language the content is written in. Our website uses English as its language. The head tag comes next in our structure. This section contains important metadata tags. It also holds the title tag for our page. The first metadata tag defines the character set for the web page. We are setting it to UTF-8. This encoding is the modern standard. Using UTF-8 is the recommended standard for HTML5. This character set includes virtually every character and symbol you could need. This means visitors to your website will be able to view all the content correctly. They will have a smooth and problem-free reading experience. Our next metadata tag handles browser compatibility. It is specifically designed for users who might be using Internet Explorer. This tag instructs Internet Explorer to use its most modern rendering engine. This tag specifically instructs Internet Explorer to use its most modern rendering engine. That modern engine is called Microsoft Edge. Microsoft has officially ended support for Internet Explorer. The browser is no longer being updated or maintained by the company. Internet Explorer will now use the more modern Microsoft Edge engine. This ensures better compatibility with current web standards. Next, we have the viewport meta tag. This tag makes sure the website's width always matches the device's screen width. This setting is important for different screen sizes. A user on a mobile phone will have a much narrower browser width. Another user on a desktop or laptop will have a much wider screen. The viewport tag ensures the content adjusts to fit each device's screen width properly. This setting ensures the browser width automatically adjusts to match the device's screen. Next, we have the initial scale property. This sets the starting zoom level when the page first loads. In this case, it is set to a value of 1. A value of 1 is equivalent to 100% zoom. This ensures the page displays at its default size. Let us open our website in the browser now. This will allow us to see the title of the website. To make our project come alive in the browser, we will use a very helpful extension named Live Server. This extension automatically sets up a local development server for us. Once you have installed this extension, you will notice a button labeled Go Live appear at the bottom of your editor window. We can click on the Go Live button to launch our website. This opens the site inside a local development server. The server uses port 5500. The index.html page will open in your browser. You will notice the title at the top currently says Document. Currently, the title at the top of the browser tab reads as Document. We can easily change this title to match our project's name. Let us change it to Basic Calculators. When we update the title here, the Live Server extension automatically refreshes the page. Now you can see the title has been updated to Basic Calculator. Looking at our final design, we can see we need a main container. This container will hold an input area and a set of buttons. Let me show you exactly how we are going to structure our HTML. I will walk you through the container and the buttons we need to create. Our design will feature a main container for the calculator. This container will hold a display input at the top. Below the display, we will have a separate section for all of the buttons. Let me highlight this section for you. I will use a different color to make it clear. This specific div has the class of buttons. It will contain all of the calculator's buttons inside of it. Each button has its own specific class assigned to it. This helps us style and control them individually. We assign specific classes to each type of button. The number buttons get the class numbers. The operator buttons get the class operators. The equals button gets the class equals. Finally, the clear button gets the class clear. Alright, let us proceed with building this structure now. Let us position the website preview on the right side of our screen. This setup allows us to observe all modifications instantly. Let us arrange our windows for a better view. Please position the Visual Studio Code window on the left side of your screen. You can do this easily by pressing the left arrow key on your keyboard while holding the Windows key. Let us close the File Explorer panel. We will now work inside the body section. This is where we will build our calculator structure. The first element we need is a div container. This div should have a class name of calculator. Now we can do this by typing .calculator. The text editor will then suggest the correct code for us. When you type .calculator into your editor, the autocomplete feature will automatically suggest a div element with the calculator class. You can then press Enter to accept this suggestion. You can press the Enter key to accept this suggestion and insert the element into your code. Now we have our main calculator container in place. Inside this container, we will add an input field for the display. This field will be used to display the numbers and results. We are setting the input type to text. We will also assign an ID to this input field. This ID is important because we will use it later. We need to target this specific input with our JavaScript code. This identification is essential for our project. We will use it later to control the display with our programming. Now, I want to explain what we are going to do next with this input field. We want to set this input field to be read only. This prevents anyone from typing directly into it. Let me explain the read-only attribute. It should be placed as an attribute on the input element itself. This setting makes the input field a display only. This input field is going to display our final result. We are adding a read-only attribute to it. This prevents anyone from typing directly into the display. The read-only attribute turns this input into a display-only element. This means you cannot type anything into it directly. Without the read-only attribute, you are able to type directly into the input field. This is something we want to prevent in our calculator. We want to make sure users cannot type directly into the input field. This prevents any manual entry and keeps the interaction controlled by our buttons. We want to restrict direct typing into the display. The calculator should only be operated by clicking the on-screen buttons. Inside this container, we will create another div element. This div will have a class named buttons. All of our calculator buttons will be placed inside this specific div. Our first button will have a class name of clear. This class is used to identify the clear function. This button will display the letter C for clear. It is important to create a button element here. A div element would not be suitable for this function. Let's create a button element for this clear function. We will give it the letter C. We have successfully created our first button element. You can see it appears on the screen now. The order we place these buttons is very important. We need to follow this specific layout to match our design. Our first button is labeled C for clear. Next, we have the / symbol for the division operation. Then, we add the star symbol for the multiplication operation. Let's proceed with creating the buttons in this specific order. This arrangement will help us build the correct layout. Moving further along the row after the number 6, you will notice the equals button comes next. After that, we have the numbers 1, 2, 3, and 0. Finally, we add the decimal point button to complete the layout. To get our layout to match the reference design exactly, we need to follow this specific order. This next button will be assigned a special class. We will call this class operator. This button will represent the division operation. It uses the / symbol for this mathematical function. Now we need to add 2 more operator buttons. These buttons will be for multiplication and subtraction. I will copy this button by pressing Alt plus Shift plus the down arrow key. Our next operator is the multiplication sign. We use the star symbol for multiplication. After that comes the minus sign for subtraction. We have finished creating our first 3 operator buttons. Next, we are going to add the number 7. We will also add the numbers 8 and 9. Each of these will be a button. We will give each button a class called number. We need a button here for the number 7. We can duplicate this button 2 more times. Use the keyboard shortcut Alt-Shift with the down arrow key. We can copy this button and change its text to an 8. The next button we need to create will be for the number 9. We can assign it the number class as well. That wraps up our number 9 button. Let's move on to the next step. Next, we will create a button for the plus operator. We will assign it the class of operator. Next, we will create the button for the equal sign. This button will be used to calculate our results. Next, we need to add the numbers 4 and 5. These will be 2 separate buttons. Actually, I meant to say this should be the plus sign button. The next button after the number 9 is the plus sign. This operator is used for addition. Next, we will add 3 more number buttons to our layout. These buttons will represent the digits 4, 5, and 6. We will assign a class of number to this button. We will now create the button for the number 4. We will copy this button element. We can use the same method we used before. Let's change this next one to number 5. The following button will be number 6. Next, we have the equal sign button. This button will use a different class called equals instead of operator. We will now add the final number buttons. These are for the digits 1, 2, 3, and 0. Looking at the buttons we have just created, you can see the numbers 1, 2, 3, and 0. We will now create another button for our calculator. This button will have the class of number. This button will display the number 1. We will copy this button 3 additional times. We can use the keyboard shortcut for this task. We will add 3 more number buttons here. The next 3 buttons will be 1, 2, and 3. We finish this row with the number 0. Next, we are going to create our final button. This button will be for the decimal point. We will give this button a special class name. This button will represent the decimal point. It is going to be a period symbol. We have now finished creating the HTML structure for our calculator. We have successfully created our HTML file containing all the necessary elements. These elements include the buttons, the main container, and the input field. The current appearance is just the default browser styling. It is purely structural HTML without any custom design yet. We will transform this basic structure into an amazing and beautiful modern design. This transformation will happen in the next section using CSS. In the next section, we will focus on the styling for our calculator. We will use CSS to create a modern and visually appealing design. That concludes our work on the HTML structure. We will move on to styling the calculator in the next video. So in the last section, we have completed the HTML part of the project. We successfully created all the necessary buttons, including the numbers, the equal sign, and the clear button. Now, we will focus on the visual design of our project by applying CSS styles. Looking at the finished calculator, you can see we have a modern design. This includes a subtle shadow effect inside the input field. The buttons also have their own shadow effects for a cohesive look. We will also add a hover effect for when you move your mouse over the buttons. This hover effect will include a smooth color transition to make it feel more interactive. Additionally, we have a shadow effect for a modern look. Let us open Visual Studio Code and access the File Explorer panel. You can open this panel by pressing the keyboard shortcut Ctrl+Shift+E. We will create a new file within our project directory. We should name this new file style.css. Before we can use this CSS file, we must link it to our HTML document. This link is placed at the top of the HTML file. We write the word link to create the link tag. Then, we select the third suggestion from the editor. This specific option is the one for linking a CSS file. This feature will automatically generate the link tag for our style file. The href attribute simply points to our style.css file. Both files are located in the same project directory, which is named Basic Calculator. For the address, we only need to specify style.css. This tells the browser where to find our style sheet. It establishes the relationship between our HTML and the CSS file. Let us begin our styling by applying some foundational styles to all elements on the page. To do this, we will add a star sign to our styles. First, I want to change the box sizing property to border box. This setting ensures that padding and borders are included within an element's total width and height. Setting the box sizing property to border box achieves a specific goal. This setting ensures that any padding and borders you add to elements will be included within their total specified width and height. Without this, the padding and borders would be added on the outside, which could disrupt your layout and cause elements to overflow. Without this box sizing setting, we will run into some layout issues when styling our input fields. The padding and borders would not be calculated correctly. I will show you what happens to our styling if we do not include this border box setting. You will see how the elements behave differently without this important rule. We also want to remove the default margin that browsers add to the page. We will set this margin to 0. This step removes any extra space around the elements. This gives us a clean starting point for our layout. Now that we have completed the basic styling, we will begin with the main calculator container. This is the div element that wraps around all of our calculator components. We can target that calculator container using its class name. We simply write .calculator in our CSS file. This works because we assigned the class of calculator to our main div element. To target this calculator class in our CSS file, we use a dot followed by the class name. This method allows us to apply styles specifically to that container. Let us begin by updating the background color of our calculator container. We will apply a light gray shade using the specific color code F2F2F2. You can already observe the visual difference on the screen. Let's add some padding to our calculator container. This padding creates space inside the container. It pushes all the elements inward from the edges. Let's set the padding to 20 pixels for the calculator container. This will create some breathing room inside the calculator. After that, we will add some margin to the container. First, we set a maximum width of 400 pixels for our calculator. This will limit the overall size to 400 pixels. Now we need to center this container on the page. We want to center this calculator container on the page. This will position it nicely in the middle of the screen. To center our calculator container horizontally on the page, we set the top and bottom margins to 0. Then we set the left and right margins to auto. This automatically creates equal margins on both sides. This simple technique easily centers the element for us. Now that our container is centered with the margin settings, we can move on to adding a border around it. Let's add a border to our calculator container for better definition. We will create a solid line border that is 1 pixel thick. The color for this border will be a dark gray, specifically the hex code CCC. This darker shade will create a nice contrast against our light gray background. We should also add a box shadow to our calculator. This shadow effect will create a subtle depth. It makes the calculator appear to float slightly above the page. Let me explain what the box shadow property does for our design. We want to set the horizontal shadow offset to 0 pixels. Then we set the vertical shadow offset to 2 pixels. You can see we have a shadow along the y-axis. The shadow has a blurriness of 5 pixels. We will use RGBA to define this shadow color. RGBA stands for red, green, blue, and alpha. This format lets us create a color and control its transparency. We do not want a fully dark shadow. Using RGBA allows us to have a shadow with some transparency. This creates a softer and more modern visual effect. We are going to set these specific numerical values for the shadow. This combination will produce a visible color for our effect. The alpha component specifically controls the transparency level. You can think of it as the opacity setting. We use 0 for red, green, and blue to create black. Then we set the opacity level to 30%. This gives us a semi-transparent shadow effect. The correct term is RGBA. It stands for red, green, blue, and alpha. That is the correct way to write the RGBA property for the shadow. This RGBA value includes red, green, and blue color channels. It also has an alpha channel for transparency. This shadow effect gives our design a nice depth. Now, we should also round the corners of our calculator. Adding a border radius will make those edges soft and modern. We want to make the corners rounded for a more polished appearance. This creates a softer and more modern look for our calculator. Now we will add a border radius to our calculator container. This will give each corner a nice rounded appearance. We will set the radius to 5 pixels for a subtle curve. You should now see the rounded corners appearing on our calculator container. This completes the styling for the main calculator element. Let us add some margin to the top of our calculator container. This will create some breathing room above the calculator. A value of 30 or 40 pixels for the top margin should be sufficient for this purpose. That completes all the styling for our main calculator container. We have successfully centered it and applied all the visual effects. Now let's move on to styling our input field. This is the area where all our calculations will appear. We can target the input field specifically by its unique identifier. This is possible because we gave it the ID of result. We can target the input field by using the pound sign for its ID. We type result and then open our set of curly braces. Next, we set the width property to 100%. Then we add a padding of 10 pixels to create more internal space. Finally, we change the font size to 24 pixels for better readability. This change will increase the font size significantly. We cannot see the effect yet because the JavaScript functionality is not yet implemented. The JavaScript will handle capturing all the button clicks and displaying the results in this input field. We are going to remove the default border entirely by setting it to none. Instead of a border, we will create a shadow effect for the input field. This shadow will be an inset shadow, meaning it appears on the inside of the element rather than projecting outward. This creates a nice sense of depth for our design. We will add a box shadow that matches the one we just created. This time, we want the shadow to appear inside the input field. We can use that exact same shadow color. This will keep our design consistent. I am going to copy this box shadow property. This gives us 0 for the x-axis offset and 2 pixels for the y-axis. It also gives us 5 pixels for the blurriness and the same color. You can see the shadow currently appears on the outside of the element. I want this shadow to be on the inside instead. To achieve this effect, I will simply add the word inset right here. Now you can see the shadow appears inside the input box. This creates a nice sense of depth for our design. We will also add a border radius of 5 pixels. This will give the corners a smooth, rounded look. That completes the styling for our input section. It is important to demonstrate what happens without the box sizing property. This will show you why that initial setting was so crucial. Let me show you what happens without this important setting. If you remove the box sizing property, you will see a visual issue appear. The padding we added to the input field will now be applied as extra width. This demonstrates why the box sizing property is so crucial for styling elements like input fields correctly. Let us bring back that important box sizing border box setting now. This will ensure our elements calculate their dimensions correctly. Let us move forward with styling our calculator buttons. We will begin by targeting the container that holds all of them. First, we need to target the main container for all the buttons. This is the div with the class name of buttons. Now we target the buttons container using dot buttons. We open our set of curly braces for the CSS rule. Inside here, I want to apply the display grid property. We are going to use a display grid for this container. This will turn our button layout into a flexible grid system. The display grid property is what creates our grid layout. It first establishes a structured container for all of our buttons. Currently, the grid places each button in its own separate row. We will design the layout differently. Next, we need to change the display property for our grid. Specifically, we are going to define the grid template columns. We will use the repeat function for our grid columns. This will create 4 equal columns for our layout. Each column will be set to 1 fractional unit. Let me explain what this FR unit means. It stands for fractional unit. Let me explain what this means for our layout. This grid template columns property is a very useful CSS feature. It specifically controls the size of the columns within our grid layout. The repeat function with 4, 1, fr values creates 4 columns of equal width. This repeat function creates 4 equal columns for our grid layout. Each column will be exactly the same width. This is achieved using the fractional unit system. As you can see, we now have 4 equal columns. The term FRs stands for fractional unit. This unit is used to divide up all the available space within the grid container. The FR unit automatically calculates and uses all the available space within the container. It divides this space equally among the columns we defined. The FR unit automatically calculates the available space for the grid layout. It then creates 4 equal columns using that available space for our calculator design. This setup creates our grid container structure. The grid container will hold all our calculator buttons in an organized layout. This grid container will divide into 4 columns of equal size. This layout is exactly what we want for our calculator design. Now we need to create some breathing room between our calculator buttons. Let's add some space to separate them visually. To create some breathing room between our buttons, we will add a grid gap. This will place a consistent space between all the grid items. Let me find the exact CSS property we need for this spacing. To create some breathing room between our buttons, we can use the grid gap property. Let's set this grid gap to be 10 pixels. We will add a 10 pixel gap between all of our grid buttons. This creates clear visual separation. We also want to add a top margin of 20 pixels to the entire button container. Our layout is looking much better with the grid in place. Now, we need to style each button individually to give them their own distinct appearance. First, we will style all the buttons together with a common design. Then we will target special buttons like the clear and equals buttons individually. For example, we will give the equals button a different background color. Now let's target all the button elements. We can do this quite easily in our CSS file. We are targeting the button element directly. This approach does not require any special class or ID selector. We can target all of the button elements directly. We just need to write the word button in our CSS file. We will now style all of our calculator buttons at once. Let's start by adding some padding around the text inside each button. We will set this padding to 10 pixels. Next, we want to increase the font size for the buttons. We will change the font size to 24 pixels, which makes the numbers and symbols much larger and easier to read. Let us remove the border from the buttons entirely. Let's break down exactly what we are going to do with the buttons next. We are going to remove the default border from the buttons. Instead of a border, we will apply a box shadow for a more modern look. We use a clever design trick to create beautiful buttons. First, we remove the standard border entirely. Then we add a box shadow to replace it. This shadow has 0 offset on the x-axis and 2 pixels on the y-axis. We set the blur radius to 5 pixels for a soft effect. The shadow color is black with an RGBA value. We use 0 for red, green, and blue with 30% transparency. This combination gives us the clean and modern design you see here. Let's add a border radius of 5 pixels to these buttons. This will give them nicely rounded corners. We want to maintain this consistent rounded look throughout our entire design. Let's change the cursor to a pointing hand icon. This gives users a visual cue that the buttons are clickable. When you move your cursor over any button, you will see it change to a pointing hand. This visual cue indicates the button is interactive. We will now create a hover effect that changes the button's background color. We achieve this hover effect by changing the background color to a darker gray. We use the color code DDD for this change. The color switch happens very quickly by default. To make that color change happen more smoothly, we are going to add a transition effect specifically for the background color. This creates a gradual shift instead of an instant switch. We will apply a transition to the background color property. The transition duration will be set to 0.3 seconds. This will create a smooth and gradual color change effect. This transition creates a much smoother color change. It makes the effect feel more polished and professional. That completes the styling for all our calculator buttons. They now have a consistent and modern appearance. Now we are going to target and style each button individually. We will apply specific styles to different types of buttons. Let's start by applying some specific styling to our clear button. This button needs to stand out from the others. We are going to style the clear button next. The clear button has a CSS class named clear. We can target this specific button in our style sheet by using a dot followed by the class name. Let's style the clear button with a red background color. We will use a specific shade of red for this button. The text color for this button will be white for good contrast. We will set the text color to white using the hex code FFF. This creates a clear contrast against the red background. The clear button now has a nice red background with white text. You can see this styling for the clear button matches our final design goal. The red background with white text creates the visual distinction we want. Looking at our calculator now, the equal sign appears larger than intended. We will adjust its size in just a moment. Next, we need to apply specific styles to the number buttons. Looking at our HTML file, you can see that all the number buttons have a class of numbers. We can target all these number buttons in our CSS by using the class selector with .number. This will allow us to style all the numerical buttons at once. We are going to apply a different background color for the number buttons. This will make them stand out from the other elements. The background color for the number buttons should be white. This is the hex code for white. We have now styled the clear button with its distinct red background. The number buttons will feature a clean, white color scheme. The decimal button shares the same styling as the number buttons. It will have a white background color and a dark gray text color for a consistent appearance. Now, regarding the decimal point, we do not actually need a separate class for it. We can manage its styling efficiently with the existing number class. We can target both the number buttons and the decimal button together. We simply use their class names separated by a comma. We can target both of these groups together. Next, we want to change the text color to a dark gray. We will use the hex code 333 for this color. After that, we can style the operator buttons. We target them using the operator class. All the operator buttons like minus and division have this class. This makes it very simple to style them all at once. Next, we will change the background color for the operator buttons. We want to use a blue color for these operators. Let me just verify that color code is correct. It should be 0074D9 for a nice blue background. The text color for these operator buttons will be white, which is FFF. The equal sign has the class name of equals. The equals button has its own specific class. This class is called equals. We target the equal button with its class selector. We will set its background color to a pleasant green shade. The specific color code we are using is 01FF70. We need to make the equals button span 3 rows. We can achieve this using the grid row property. To make the equal sign span across 3 rows, we use the grid row property. We set this property with the value span 3. We will use the grid row property with a value of span 3. This will make the equals button stretch across 3 rows. This grid row property expands the equal button to span 3 rows. You can clearly see this visual effect in the layout. Using display grid makes designing a calculator layout very straightforward. This approach handles the arrangement of elements with ease. We set the text color to white using the hex code FFF. That completes the styling for our calculator. The design is fully responsive and will look great on both mobile devices and larger screens. The design remains consistent across different screen sizes. It looks great on both mobile devices and larger screens. You can see the design maintains its clean appearance at various zoom levels. It adapts beautifully whether you are viewing it on a large screen or a smaller mobile device. This design works beautifully across different screen sizes. We can maintain this exact layout on both mobile and desktop devices. We have now successfully created and styled our entire calculator project using CSS. The design looks modern and professional with all the visual effects we wanted to achieve. Now that our calculator looks great, we will bring it to life with JavaScript. We will add the functionality that makes the buttons work. We will add event listeners to each of these buttons. This will allow the calculator to respond when you click on them. We will gather all the information from these buttons. Then we will trigger a function to calculate the final result. This result will be displayed in the input field at the top. We also need to implement a clearing function. This will be activated by pressing the C button. This functionality will be quite straightforward to implement. We will use a special JavaScript method for the calculations. This method is called eval. Most calculators online use custom code to handle the math manually. However, there is a newer built-in JavaScript method that simplifies this process. I will demonstrate this efficient technique in the next section. We will now move on to the JavaScript part of the project. This is where we will add all the functionality to make our calculator work. In the last section, we have completed the CSS section of our project. Let's enhance our project with new capabilities. We will be using JavaScript to add these interactive features. In this section, we will implement the core calculator functions. These functions will handle all mathematical operations. The first step in this process is straightforward. We need to create a new JavaScript file within our project folder. Let us return to Visual Studio Code. Press Ctrl-Shift-E to open the Explorer panel. You will see your project folder named Basic Calculator on the left. We will create a new file inside this folder. I will name my JavaScript file index.js. Just like we connected our CSS file earlier, we must now link this new file to our HTML document. This time, we will not place the script in the head section. We need to add it right at the end of the body section. This is a crucial step because we must wait for all the HTML elements to finish loading in the browser. Only after they are fully loaded can we successfully access and manipulate them with our JavaScript. We begin typing the letters SC and wait for the autocomplete suggestions to appear. We select the second suggestion from the list, which includes the source attribute. This script tag connects our HTML file to an external JavaScript file. The src attribute specifies the file's location. Since our JavaScript file is in the same folder as our HTML, we can simply write the file name, index.js. This relative path is all we need to link the file correctly. Our first step involves accessing the HTML elements from our JavaScript code. This access allows us to manipulate these elements and add interactive features. Our goal is to add event listeners to each of these buttons using JavaScript. To do that, we first need to gain access to the container div that holds all of the buttons. We could add an event listener to each button individually. That approach would work perfectly fine. There is a much simpler method available to us. We can use a for loop to go through all the buttons inside this container. This loop will allow us to target each button one by one efficiently. To select all the button elements on our page, we will create a constant variable. We will call this variable buttons elements because it will hold all our button elements. We want to get every single button on the page. We can do this by targeting the document object. We then use the query selectAll method. This method allows us to select everything with the button tag. Let us test our selection by logging the buttons element to the console. I will copy this line and place it in our file. You can open the browser console by pressing the F12 key. After you refresh the page, you will see we have captured all the buttons. This appears as a node list containing 17 items. Let me clarify the button count for our calculator. We have 10 number buttons from 0 to 9. We also have 4 operator buttons for addition, subtraction, multiplication, and division. This gives us a total of 14 buttons so far. We must also include the decimal point button and the clear button. Finally, we have the equals button for calculating the result. We have successfully selected all the buttons with our code. This gives us complete access to each button element. Looking at these buttons, you can see they have different classes. Some are designated as clear buttons, while others are marked as operators. Our next step involves adding an event listener to every single button. This will allow our program to detect when a user clicks on any button. Let us delete that console log statement for now. Instead, we are going to create a for loop. We will create a for loop to go through each button. We will initialize a variable called I and set it to start at 0. This variable, I, will increase until it is less than the total number of buttons. We can get that total number by checking the length property of our button elements collection. The length of our button elements is 17. This condition checks if our counter is less than the total number of buttons. Using the button's element length property is the correct approach for this. We need to correct the for loop syntax by adding a semicolon here. We place another semicolon after the condition. Then we increment the counter variable by 1 each time the loop runs. We will use the increment operator to increase the value of I by 1 with each loop iteration. The variable I begins at 0 and increments by 1 each time. It continues through each iteration until it reaches the end of the button elements list. The loop begins counting at 0. It continues incrementing until it reaches 16. That brings our total number of iterations to 17. Each button will be processed individually by this loop. Our loop begins counting at 0 and continues until it reaches 16. This process gives us 17 complete iterations. During each iteration, we attach an event listener to a different button. We need to target the entire collection of button elements. Then we want to access each individual button within that collection. We add an event listener to each button element. We achieve this by using bracket notation with our index variable I. This loop gives us access to each button element individually. The index value I will be 0 for the first button. It will then increment to 1 for the next button. This continues sequentially until it reaches 16 for the final button. Next, we will attach an event listener using the addEventListener method. This method allows us to detect when a user interacts with our button. We want to listen for a specific user action. We are going to add a click event listener. Every time someone clicks a button, we want to execute a corresponding function. We need to create a function for the click event. This function will handle what happens when a button is pressed. Every time a user clicks one of the buttons, we need to trigger a function. This function will then retrieve the specific value associated with that clicked button. For example, we can demonstrate this by logging the button's text content to the console. The text content is the label we see on each button in our project. The clear button shows the letter C. The following button shows the division symbol. Then we have the multiplication symbol and the numbers 7 and 8. Let's test this functionality by checking the console output. Each time we click a button, its text content should appear in the console. Let's open up the browser console one more time to see the results. Each time you click any button, you will see its value appear. For example, clicking the 0 button displays 0 in the console. This happens because we are capturing the text content from that specific button. We are successfully getting the text content from every single button. This includes the 2, the 3, the equal sign, the plus, and the minus. All of the buttons are working correctly, even the clear button. This confirms that we are correctly capturing the value of each button. We now have access to all the button values. I will replace the console log statement. Let us store the text content in a variable. We can call this variable button value. We have captured the button's value at this point. Now we can proceed to implement conditional logic based on that value. Now, for the clear button, we need to add a specific condition. We can write an if statement to check if the button value is the letter C. When that condition is true, we should call a function to clear the results. Every time someone presses the C button, we want to call this clear function. We must remember to create that function first. We will name this function clear result. Let us create this function for now to prevent any errors. We will add the actual functionality to it later in our development process. Let us move forward with completing this conditional statement structure. We need to finalize the if and else if conditions for our button interactions. Next, we need to add another condition. We will use an else if statement for this. This condition will check if the button's value is the equal sign. When the user clicks the equal sign, we will call a function to calculate the final result. This function is named calculateResult. Let us create that function and name it calculateResult. We will continue writing the rest of the if statement. The next scenario we need to consider is when the button value is a number. This could be any digit from 0 through 9. It could also be the decimal point. Otherwise, the button value could be any number from 0 to 9. It might also be the decimal point. We want to show this value on the display. This action appends the button's value to whatever is already there. Our goal is to display the number or symbol on the screen. We also need to add it to the existing sequence of inputs. We are going to call this function append value. We will pass the current button value into it. Let's create this append value function now. We will define it right here. Next, we need to create a new function for appending values. This function will be called append value. That covers the creation of our 3 main functions. Our event listener now handles 3 distinct scenarios based on which button is clicked. When the button value is the letter C, we will trigger the clear result function. This function will completely erase the current calculation from the display. If the button's value is the equal sign, we will call our calculation function. This function will process the mathematical expression and display the final result. We want to add that button's value to the display. This action will append the number or operator to the existing input field. Let us begin by implementing the append value function. Let's talk about the append value function. This function receives the button's value as its input parameter. We are passing this value when we call the function. This value becomes the function's input parameter. We now need to access this specific input value. We can write this value directly into our display field. We need to display the value we captured on the screen. We can accomplish this by writing that value into the input field element. Looking at our HTML file, you will see we have an input field. This input field has a special identifier called an ID. We gave this input field the ID of result. To access this input field in our JavaScript code, we can specifically target it using its unique ID. We need to get the input element at the start of our code. We will target it by its ID and store it in a variable. I'm going to call this variable input field element. This variable will be equal to the document object. To access the input field, we will use a specific method. This method is called getElementById. We will use this method to target the element with the ID of result. Since we already know the input field's ID is result, we can directly target that element by using that exact ID name. Now we have access to the input field element inside our append value function. We want to target that specific input field where our results are shown. We are going to set the value of this input field. We do not want to replace the current value entirely with the new button value. Instead, we want to add the new button value to the end of the existing value. We accomplish this by using a plus equals operator. This approach appends the new value to the existing one. For instance, if the current value displayed is 2 and you press the button for 3 next, the display will update to show 23. Let me demonstrate how this works in our live application. You will see the numbers appear on the display as we click them. Let me type the number 1 on the keyboard. We can see the number 1 appear in the display area. The number 1 will remain on the display. Pressing the number 2 button will then append that digit right after the 1. When you press the number 1, it appears on the display. Then, when you press the number 2, it is added right next to the 1. If we were to press the equals button immediately after entering a number, that number would be replaced entirely. For instance, typing a 4 and then pressing equals would leave just a 4 on the display. If we press the 5 button next, it will replace the current display. Our new input will overwrite that entirely. To preserve the existing numbers on the display, we use the plus equals operator. This ensures the new value is appended to the previous one. This approach is very similar to writing the full expression. We are essentially telling the value to become itself plus the new character. Using the plus equals operator is a helpful shortcut for this task. It allows us to append the new value directly to the existing one. This approach will function in a similar way. Let me demonstrate with an example. If you press the number 1 followed by 5 and then 2, you will see the numbers appear consecutively as 152. I will copy this line to demonstrate both approaches for you. The plus equals operator accomplishes this task. I will comment out the alternative method for your reference. This shows how both techniques produce a similar result. That is the method we will use for our calculator project. We have successfully captured the value from the button. This value is now stored in our input field. When we click the plus sign, we want to trigger an evaluation. This process will calculate the final result for our mathematical expression. Inside the calculate result function, we will work with the input field element. We want to take the current expression and evaluate it. We want to replace this current value with the result of a calculation. We can do this using a special JavaScript function called evaluate. This function will process the mathematical expression we have built. The eval function is built directly into JavaScript. It takes a string of text. Then it processes that text exactly as if it were regular JavaScript code. For example, we can evaluate a simple expression like 2 times 5. When we press the equals button, the display will show the result of 10. The eval function processes that entire string of characters as a mathematical expression. We receive the final calculated result from whatever operation was typed. For instance, if we enter the number 1 and then press the plus sign and another 1, the display will show the string 10 plus 1s. When we press the equals button, the evaluate function will calculate that expression. The result displayed will be the number 11. That makes sense with the plus equal sign. Our goal is to take the current value inside the input field. We want to evaluate that mathematical expression. Then, we will display the final calculated result back into that same input field. Let's try a simple example to see how this works. Imagine we type in the number 45 and then add 5 to it. When we click the equal button, the display now shows the correct result of 50. That calculation worked perfectly and gave us the correct result. For example, we currently have 50 displayed in the input field. If we press the multiplication button and then 5, we will get 250 when we press the equal sign. When a user clicks the equal sign, it will evaluate the entire mathematical expression currently displayed. This process calculates the final result for the user. The evaluate function processes mathematical expressions. It takes a string of numbers and operators as input. This function then computes the final result for you. You should now have a clear understanding of how the evaluate function works. When I have seen other online tutorials for creating a calculator, many of them handle the math in a different way. They often write separate logic for each type of operation, like addition or multiplication. Some online tutorials create separate conditions for each operator. They might write code that checks if the operator is multiplication and then performs a multiplication. This approach requires many different checks and can become quite lengthy. The method we are using with the evaluate function is far more efficient. It handles all the calculations in a single, clean step by processing the entire expression. That clever trick with the evaluate function is the core of our calculation logic. The only remaining feature to implement is the clear button. When someone presses the C button, we want to completely clear out the input field. This will reset the display to be empty and ready for a new calculation. Inside the clear result function, we will set the input field's value to an empty string. This action will completely clear the display for the user. We want to completely clear the input field. We will set its value to be an empty string. For instance, if our calculator display currently shows some numbers, pressing the C button will completely clear the display. This action removes everything instantly. We can perform a calculation and see the result displayed. Then we can clear the entire display with a single press. This basic calculator project demonstrates the core functionality. It provides a solid foundation for your web development journey. You could also add parentheses to your calculator for more complex mathematical expressions. This would allow you to group operations together and change the order of calculations. You can incorporate parentheses for more complex calculations. You might also add a feature to delete the last character entered. Adding the ability to delete just the last number you entered is also a very simple feature to implement. For example, imagine we type the number 45. We might want to delete just the last digit, the 5. To do this, we would add a new button to our calculator. That new button would trigger a function. This function would not add a new value. Instead, it would remove the last character from the display. I encourage you to try implementing this feature as a practice exercise. Feel free to share your completed work with me afterward. You have successfully created a simple and basic calculator. This project demonstrates the core functionality of a working calculator application. I hope you found this project enjoyable and educational. You have learned several important programming concepts through this practical exercise. We have learned how to use the eval function for calculations. We also learned how to add an event listener to multiple buttons using a for loop. Finally, we learned how to clear the display, calculate results, and append new values. We have accomplished many valuable skills in this project. We will continue our learning journey with another exciting project in the next one. So see you soon in the next project.